Hi. The last few years have been very turbulent. You all must have observed that everybody is jumping up and down with the buzzwords dual fuel engine, electronic engine. Life was so good with a good old SMC engine. We knew it very well and ships were running fine. So, what is this sudden urgency? Why all this chaos and confusion? Are we forced into this? What is the need or necessity for this electronic engines? In this video, we are going to talk about all these issues. What is the need for all of us to jump up and down? This video will form the foundation for all of you to understand all future engines. Welcome to Chief Engineer's Tea Time Talk. I am Ramesh and I'll pilot you through this channel. Keep watching and hope you like this video. Thank you. In this video, we will see the advantages and necessity to shift to the electronic engines. The primary aim of the engine maker was economy, that is to get the best specific fuel oil consumption. So all research and development was focused on this. Now it is time for us to revisit the basic question. When should the fuel burn to get the maximum energy transferred to the piston and not to heat up exhaust gases and lube oil and jacket water, etc.? The answer for this question was dealt with in detail in the previous videos on diesel engine combustion part 1 and part 2. We had seen that the maximum push on the piston because of the gas burning is at its maximum nearer to the TDC. So the maximum burning of the fuel and the resultant peak pressure should be as closer to the TDC on the way down. So to improve the SFOC, increasing the peak pressure limits and using the VIT principle was the trick which was being used for many years. Here you can see that without VIT, the peak pressures decrease with reduced loads. Fuel oil injection pressure also decreases, affecting penetration, atomization and hence combustion. Here you can see that with VIT, the injection is advanced at reduced loads to try and maintain the maximum peak pressures as far as possible for betterment of SFOC. But we need to note that the fuel oil injection pressure still decreases, thereby affecting atomization, penetration, and the result is poor combustion. The peak pressure limit was basically due to the mechanical strength, mechanical properties of the components, the limitations of material science. The more technology developed, the more was the peak pressure. Remember, from some 100 bar in the 1980s, it gradually climbed up to 150 bar and probably would have become 300 bar in another 50 years with the superior materials and improvement in material science. But all this came to an abrupt stop because of climate change. The higher the peak pressure, more was the NOx, and the world was becoming very sensitive to air pollution. So an end was put to this trick of increasing the peak pressure process. In fact, Super VITs, etc. were basically advancing the fuel injection timings to increase the peak pressure at low loads. You can click on the link which will be made available in the description. I would also recommend you to go through those videos if possible for better grasp on the concept. It is of interest to note that the following factors determine if the fuel is burning, which of course is a very expensive resource, if it is burning most efficiently and economically. Fuel efficiency depends on how well the following objectives are achieved. First, maximum amount of the fuel injected should be burnt without having any unburnt fuel escaping through the exhaust gas. Second, the fuel should burn such that the maximum energy released goes to power the engine and not go towards heating up the jacket water, lube oil, exhaust gas. This is minimum possible afterburning. Practically, the physical parameters available to achieve these objectives depended on: 1. How much fuel I inject. We call it as fuel oil injection quantity. Second, when exactly I inject and start the combustion. We use the terms timing of injection and then the ignition lag. The third one is how do I burn the fuel with respect to the crank angle. We call this as the injection profile. The above form the basis of the principle of fuel injection pump for a diesel engine. The other important parameter is the amount of air made available. Less air results in unburned fuel, and more air results in unnecessary increase in peak pressure and heating up of gases which don't contribute to the combustion process. So it's a waste. And this amount of air made available was depending on the exhaust valve timing, scavenge pressure, and etc. etc. Keeping in view all these requirements, large merchant ships were generally propelled by a two-stroke diesel engine, large diesel engine, where fossil fuel was injected into units with the cam. Exhaust valve was also opened and closed with the cam. Many makers used a type of pump called the Bosch pump or the jug pump. We can see here that there is a camshaft. The plunger is having a fixed stroke. The point to be noted is the stroke cannot be varied. That is, the fuel oil injection quantity cannot be controlled with the stroke of the plunger. The injection will commence when the spill ports are covered. Hence, the beginning of injection is always constant. The fuel oil injection quantity was therefore altered by varying the stopping of injection. It was done by the fuel rack and a helical groove system. We will not get into the details because I presume all of us know about that. The timing of injection was controlled by synchronizing the cam position such that the spill port gets covered at the desired crank angle. These engines with cams did a great job for so many years, but they had some constraints. The cam profile controlled the way the fuel got injected into the cylinder, also called the injection profile. Cam profile being unalterable once the camshaft was fitted created restraints in varying the injection profiles at various load demands. The injection profile was unalterable. Let's look at the efficiency of combustion basis this Bosch pump. We all know that for good combustion, it is necessary to have good atomization and good penetration. So which will result in good mixing of the air and fuel, etc. Atomization and penetration are at its best, obviously at maximum fuel oil injection pressure. Now this maximum fuel oil injection pressure is purely dependent on the acceleration given to the fuel pump plunger. Obviously this depends on the speed of rotation of the camshaft, which also depends on the RPM of the engine. The engine makers have calculated everything and fine-tuned it to get maximum efficiency and best combustion between approximately say 75 to 80% of the MCR. This is when the specific fuel oil consumption will be at its best. Now if this engine runs on very low loads, obviously the camshaft RPM will be small and hence the fuel oil injection pressures will also be less, which will result in poor atomization and improper penetration. This will increase unburned fuel and result in inefficient burning or increase in the specific fuel oil consumption. So this aspect cannot be overcome with any trick like the VIT or Super VIT, where we can tamper to some extent with fuel injection timings. So the efficiency of the engines at low loads was a great challenge, which got overcome to a certain extent with VIT, but left much to be desired. Again, I recommend you to see the earlier videos in this channel on VIT also. Here you can see that the profile here is at full load, nav full. At full ahead it would be, at half ahead it would be like this. At slow head, it will be like this. Thus, we see that at low loads, the injection pressures are less, which result in poor atomization. In order to improve combustion, we need to have the flexibility of manipulating injection profiles. A camshaft will never ever allow us to do so. We needed to get rid of the camshaft to increase the flexibility for manipulating the injection profiles. We also need to get rid of the camshaft to open up possibilities to burn future fuels, which may require different profiles, and the engines should also be capable to burn multiple fuels basis the availability. Now, betterment of specific fuel oil consumption had to be reworked from basics, from a completely new perspective. The need for efficient burning of the fuel will always make sense from the commercial perspective. This is where the development of electronic engine got necessitated, with or without MARPOL Annex 6. MARPOL Annex 6 added limits to SOx and NOx and put some guidance parameters. We'll stop this video here, and in the next part we will look at the basic concept of combustion in electronic engines and the implementation to arrive at electronic fuel injection component.